Good afternoon, sir.
Hello, good afternoon.
Yes, sir. Good afternoon, sir. Good afternoon.
Yeah, you're able to hear, right? Yeah.
Yeah, yes, sir. Hearing. We will shortly start, sir.
Okay.
Prabha, madam.
Yes, sir. Good afternoon, sir.
Good afternoon, madam. Whether we can start the program, madam?
Sir, shall we wait for 5 more minutes, sir? The participants are
Joining. Okay.
Yeah. Sir, Selva Chandran, sir. Good afternoon, sir.
Yes, madam.
Good afternoon, madam.
Sir, this is Prabha. Shall we wait for 5 more minutes, sir?
Yeah, no problem. No problem.
Yeah. Thank you, sir. Thank you.
No issue. No issue. Yeah.
சார் கோபாலகிருஷ்ணா சார் ரெக்கார்டிங் பண்ணுங்க சார்.
பண்றேன் மேடம். Once we will start the program, I start recording.
இல்ல சார் இப்பே பண்ணிடுங்க சார்.
Okay, no problem.
This call is now being recorded.
Chandra madam,
சார் சொல்லுங்க சார்.
வீடியோ முதல்ல ப்ளே பண்ணிட்டு ஆரம்பிக்கலாமா? இப்படி
ஆமா சார் வீடியோ போட்டுக்கலாம் சார்.
டைம் ஆகிட்டே இருக்குது, அதுதான்.
அதான் சார் வீடியோ போட ஆரம்பிச்சிடலாம் சார்.
ஓகே. Selvachandran sir.
Yeah, please.
Sir, just formally we are putting our department video for 2 or 3 minutes, sir. Then we will start the program, sir.
Okay.
Surendra sir available, madam? Illata na podatuma. Hello, Chandra madam.
Sir, I told Dinesh sir to play no.
இல்ல அவர் சுரேந்தர் போடுவாருன்னு மெசேஜ் அனுப்புறாரு, நான் போடட்டுமா?
நீங்க போட்ட காலையில ஆடியோ வரல சார்.
இது கேட்டிருக்கேன் நான், இப்போ ஆடியோ how to put that கேட்டிருக்கேன். ஓகே. சுரேந்தர் அவைலபிள், சுரேந்தர் சார் அவைலபிள்.
அவர்னே போட விட்டுருங்க சார். சுரேந்தர் சார்.
Sir, ma'am, he is not available. Sir, you can sir, you can.
Okay, madam. Okay.
Both are not available, ma'am. So
okay, madam.
Sir
Okay.
will play
Okay.
the video.
Okay. Madam, it is not coming properly. Chandra, madam,
Okay, sir. Hemalakshmi, start ma.
start
Yes,
பண்ணிக்கலாம்.
ma'am. A very good afternoon to all. Firstly, I now request Dr. Gopalakrishnan sir, Professor from Department of Civil Engineering, to deliver the welcome address.
Good afternoon to all. I welcome all the participants and Dr. Selvachandran sir, senior structural engineer from the Singapore. I welcome you, sir, for this program. And on behalf of the Department of Civil Engineering and also the EASWARI Engineering College, I warmly welcome you for this program for delivering the technical lecture in spite of your busy schedule. Thank you, sir, coming over here. Please, sir.
Thank you, sir. I feel highly privileged to introduce the guest of today's session. Dr. P. Selvachandran is a structural engineer from Mott MacDonald, Singapore. He did his PhD in structural engineering from Anna University, Chennai, and master's in structural engineering from Bharatiyar University, Coimbatore. He has about 21 years of industrial experience. He has 11 years of experience in underground structures of metro rail and tunnel structure. He has 4 years of experience in national and international airport projects, including Salalah Airport, Mumbai Airport, Delhi Airport, and Durgapur Airport. He has 4 years of experience in commercial and office building construction, having worked with IT campus development of CTS Kolkata and LT Vijayawada, etc. He has experience in slab load, SPT, plate load test, and lab test. He has been a co-investigator for AICTE-sponsored research projects and has published 24 journals and conferences, and also has experience in software development. About his specialities, he is specialized in design development, technical review, construction support, and design coordinations. Tender-stage technical document preparations as per FEDIC and GC contract requirements, pre-tender project report and advanced engineering study, and contractual claims report for change of scope. His achievements include successful completion of metro rail, airport, and building projects that have received best customer satisfaction reports. He has led and managed a number of projects and team of professionals and has developed business through receipt of new projects. He has also resolved design and site issues through technical solutions. We are extremely privileged and it's our pleasure having your presence in this webinar, sir. Sir, I kindly request you to start with the webinar.
Thank you. Thank you for your warm welcome. Respected convener Dr. S. Lavanya Prabha, Professor and Head, Dr. R. Gopalakrishnan, Professor and Head, Mr. L. Chandrakantama, Assistant Professor Civil, Mrs. G. Prabha, AP Civil, and Mr. A. Mohan, AP Civil. Thanks for the opportunity during this pandemic situation to share their knowledge and enhance the group of technical engineers in our engineering society. It really a critical period. Everyone knows how struggle we are managing this Corona COVID period. It is great. We need to thank them for organizing this critical period to enhance the knowledge. Thanks for the management for the providing opportunities. Let me share my screen. So, presentation. Yeah. I hope you can able to see the screen now. Yes.
No,
Can you off your video first, sir? Then only you can, I think, the video of your profile only we are seeing.
Oh, maybe I need to switch off the video, then we'll just have the screen. Can you able to see the screen now?
No, sir.
It's on share. showing.
Again, you can refresh and you can go in the
Yeah.
present now mode, sir. Present now.
Yeah, I'm just selecting your entire screen.
Yes, sir. Yes. Then you can select the PPT.
I hope you can able to see the screen
Yes,
now,
sir.
I guess.
Yes.
Yeah,
Yes.
good. So
You can put
mainly
the
the yeah.
slideshow mode, sir. Yes,
Yeah.
sir. Now it is visible. Yes, sir.
I hope everyone can able to see the screen. See the global challenges in metro rail transit system. So this is what the topic which I have chosen to express my knowledge in this infrastructure area. So I started this metro rail projects where the global demand mainly across the world. So they have major issues on the congested traffic conditions. So India also 1990s we started to incorporate in Delhi. Then slowly we have expanded to other major cities. So I just involved from Delhi Metro, then extended my services in Chennai Metro Rail projects from phase 1 and phase 2 extension. Currently, I'm also in phase 2 as well. And then I moved to Southeast Asia, so done some Qatar metros and Dubai metros. Then I moved to Southeast Asia, Singapore metros, Thailand metro, and Jakarta metros, and Australia metros. So quite long time I was spending in this metro field. So I thought of sharing my experience. What are the current global challenges? So there are a lot of challenges, mainly due to this urbanization of world. So the world is moving towards faster urbanization. That has become a big problem now because of COVID, right? So still, this urbanization creates congested traffic conditions. We did not only in India, we can see the traffic conditions. If you look at in Japan, it was quite very, even though developed country, they were struggling to manage the traffic. And Jakarta, they had a similar kind of situations. It is more of like Mumbai. So Jakarta population is almost similar kind of things. And Singapore, we have a huge metro networks to reduce the traffic congestions. This is the biggest challenge. Only providing metro rail alone is not the solution. So we also need to have a global connectivity of bus transit systems, all integrated transit systems only to resolve this problem. Not only that, as you know, the current scenario, because of the high congested traffic, we can see in day-to-day, Bangkok has a bit toxic level it crossed. Even our Delhi, every year we are facing this problem. Also, the global warming major reason, one of the major reason is the industrial and traffic pollutions across the world. So these need to be sorted out. So that is where we were trying many options to resolve it. So the best options, we go for a mass transit systems. So instead of going individually, everyone's having a car systems, or if everyone having an individual vehicle, which will always add up more global impact. And not only the global impact, also affect the business, also affect the time, what we spend more time on the road, not on effectively on our work. So in order to resolve the major, so around 90s centuries, we get into integrating all BRTS bus road traffic systems, so mass pulling the people. And suburban, you have long rail systems between cities, and you have a suburban systems through long rail systems, EM vehicle motor systems. You have AC motor systems. Generally, we use for suburban systems. MRTS high-speed rail systems. We go with MRTS systems. So MRTS again, we further classify it into so many based on the applications. Say metro rail we use in major cities like metropolitan cities, where we need more stations and a faster way of moving the mass people between one point to other point. And we have a monorail systems. Currently, we are also introducing metro light in small cities with a smaller speed of 25 km per hour. We also have a metro neo. It is tier 2 and 3 cities. It's like more of like moving on the road. We are moving back to 18th century, what we adopted in London, the same kind of metro neo systems. It is also we are planning in Chennai metro neo systems. And also we are looking for a high-speed rail system between Ahmedabad to Mumbai, bullet rail systems, faster rail systems, and nano tube systems. Also we are exploring various options. So all the requirements depends on the functional and the city congested requirements and business demands. So the global challenges also increases. So as an engineer, we look at technically what is the challenges in underground mainly. I'm not going to touch all the topic because it is a very vast field. So I'm going to specifically touch only underground. What are the engineering challenges? I'm not going to touch any global other non-engineering stuff. Let's talk specific to the engineering, particularly about structural. So let's touch about underground structures. So underground structure, why it is needed? Because the above ground is completely occupied by BRTS systems. So we forced to use underground systems. It's costlier, but it is quite environmental friendly. So and also we can easily create a clean cities and easy way of mobilizing from one point to other point in a mass manner. Is always easier going for underground systems. So underground systems, what we have always generally we used to have a station between 2 points is underground and connected by a tunnel systems, mine tunnel, or maybe we may go for NATM tunnels. And generally the construction methods what we adopt is cut and cover method. We go either we cut and cover the portions. It may be top-down method or maybe bottom-up method. It's more of like a building construction, but what we do here is we start from the slab, then we construct a foundation. That we call it as a top-down method. We go for a bottom-up method, similar like a building methods. And tunnel boring we do between stations. So tunnel precast elements or maybe casting elements we use to cast between stations. And also we do mining, we do box pushing, pipe jacking, all depends on the criticality of the problems. So the challenge is also associated with it. The structural challenges also occur, not only structural and construction and environmental challenges also associated with it. Mainly about underground structure, we call it as a geostructure because it is not purely structural. We need to thoroughly study on geological and structural integrated model. So we need to understand how the soil is behaving with our drained or undrained conditions and how the structure is behaving. So generally what we do, the top-down, as I said earlier, the top-down construction method, we go for a guide wall to construct a first retaining wall. We call it as a diaphragm wall. This diaphragm wall, once we construct some temporary plunge column. So once this plunge column, can you able to see the screen now? Any problem?
Yes, sir, it is visible, sir. You can continue. Dear, kindly mute yourself.
Okay, is it clear, right?
Sir, you can mute Aarti.
Yes, sir. Clear, sir.
Yeah. So what we do, we construct a diaphragm wall, then we construct a middle supporting columns wherever if needed. Maybe a composite column, steel concrete composite columns. And also we excavate and construct roof slab and backfill it. So then we allow for a traffic. Why do we need to do this? Because to create a less impact on the surface conditions. So maybe the traffic management is a big challenge here. Maybe some associated activities like some colleges will be there above ground. So we need to provide access for the functional whatever above ground requirements need to be satisfied. That's why we do this top-down method. So again, when we go for a concourse slab, we do it in the confined zone. We excavate and we go with the confined environment. We need to excavate underneath and we need to provide proper lighting, proper ventilation systems and construct a concourse slab and go down further construct a base slab. That's all. This is about top-down construction method. And the simple way, the bottom-up method as well the same. So when we do here, we construct retaining walls. Once construct a retaining wall, then we go for a temporary support, maybe steel support. So we start excavate and provide a temporary strutting to hold the diaphragm wall, because the diaphragm wall may be 20-30 meters. Generally, the depth is also depends on how the alignment it is. If you look at in our Singapore metro, there are multiple alignments are crossing each other. So sometimes we go more deeper, 50 meter down or 70 meter down, we go deeper and we construct the stations. So this scenario, we may end up with providing a more number of lateral support to hold the diaphragm wall. So this diaphragm wall is literally like act as a cantilever wall. So when we give a proper support, then it will become a supported like a continuous beam. So the engineering aspects, what we need to look at for both top down and bottom up, the real important challenge is we need to assess the sequential analysis, not doing the devolve just for lateral load. We need to assess for each conditions how this behavior. So for example, these conditions, the diaphragm wall will be supported on both sides and only roof slab and concourse slab. So the behavior, complete behavior is bending behavior is towards inside. So sagging will be only inside. So, but when you look at the next stage, this will become different. The bending behavior will change here. So just reverse bending will occur, cobbing will occur here near the concourse slab support. And again, the sagging will take place. So the bending moment and the behavior also changing at each stage of construction. So we need to assess for each stage of construction. Not only that, we also need to understand the soil conditions. The soil behavior also vary with respect to the water table conditions. If you have a drained conditions, drained soil condition, the behavior will be different. For undrained condition, the behavior will be different. So the real challenges comes once if you do combine the geostructure analysis, then you can easily assess the behavior of envelope behavior of the structure based on the different design only. So again, for the case of concourse slab, maybe a thin slab, but still you may have a good amount of axial load will act on the concourse slab. So sometimes we may need to design the concourse slab not only as a bending member, also we may need to consider for axial. So also here the connection during the temporary stage, because we are creating the temporary plunge column, then we are giving a connection. So fixity we are creating between slab and column through proper coupler systems or welding systems. So the connection play a major role. So maybe a shear connection we start with, and then when structure into the final stage, we go with a moment connection. So not only the loading, not only the behavior, also the support system as well will change for each stage of construction. So, and these all need to be kept in our mind when we are doing the design for underground structures. So this is what we do. Then for a tunnel boring, we know that both tunnel systems, generally we do the by tunnel boring machine. So the easier way is applying a bentonite and then rotating this cutter head. So with the wheel, cutter wheels, so it will cut and then it releases the oil, soil and get collected here. So this tunnel boring machine, once we cut, this machine will start push in front of it through the hydraulic jacks. Then we parallelly lay the segments, precast segments. So it looks like the shape is circular. So we feel that, okay, it's a compression member, but it's not actually truth. So each segment, when it moves, when it fixing, when it lifting, so each stage, the behavior is changing. So we need to assess sequential study on each, right from the casting to till fixing in positions. So not only that, the cutter head positioning also play a major role, because the cutter head, the extent of lateral pressure we need to apply equal to the lateral pressure what anticipated pressure will act on the seal. So this all integrated study provide a global challenges, which currently we have all automated. Still, we have UV ray systems. There may be a maybe you can see there may be a holes in front of it, or maybe some chamfer, existing chamfer in front of it. So there are many possibilities. Say, for example, if you look at the tunnel boring machine, I'm opening the video. Yeah. I hope you can able to see the video now, correct? I hope you can able to see the video.
Yes, sir.
Right?
Yes, sir. Yes, sir.
Yeah. So the main point is the tunnel, that's what I said, when it rotates. So when it rotates, it is collecting all the mud, and then it's connected through the chamber, it collected. So the major challenges here when we do the So when you look at here, what we do simple equilibrium conditions. So whatever the lateral force due to the earth pressure and due to the water pressure, and if any overburden pressure, equivalent pressure we need to apply. So in such a way that we are maintaining the stability of the cylinders. So see the importance of the perfection. If we are, even for small unbalance, leads to there will be a sinkhole at the top. You can see many newses, even in Chennai. You can see many newses about sinkhole occurred on the road. Sometimes the vehicle may go inside. So because the degree of accuracy play a major role. Now anyway, we have automated systems. Still, it will calculate automatically. What it will do, it pass the UV ray here, and if any holes present, it will assess automatically, and then it calculate the possible lateral load. Then manually we adjust with micro level, and in such a way that we try to maintain the equilibrium conditions. So the concept is simple, but the degree of accuracy is highly important. So when we move forward again, not only that, if you look at the segment, how they are laying the segment, when we, so the segment, if you look at the complete segment is, when you look at it as a circle, it is a compression member, it is very simple, it can take more load. But when we take individual segment, it carrying load and lifting load. So when you are lifting, you may need to check for punching. There is a possibility of punching while lifting on the point. And when you look at here, this segment, it is getting lifted and it is getting rotated as well. So we need to design the segment not only just for the axial load, also for just keeping in position. See, the segment is getting fixed and then getting rotated. So the joint has to be designed for various angle conditions, say 30-degree rotation, 360-degree rotations, how the dead body is moving. So accordingly, we need to design all the connections and the segments. Not only that, currently we are not even using the reinforcement. We are going for a steel fiber reinforced segment. We are using glass fiber reinforced segment. Mostly that provides sufficient restraints against the compression load, as only we are designing locally for the connections. So, and this jack is used to hold in position and then fixing the complete segments. And when we look at here further, when we go further, so you can see once fixed in positions, the conjoints do not get leaked, so we grout it outward. So once you do the grouting out to sealed, so there won't be any much leakages. In case if you find some more major leakages, we also inject from grout from inside the tunnel, and we make sure that there won't be any leakage inside. So the major point is, the challenge is, the concept is simple. We need to make sure that the equilibrium condition is properly maintained. The seal is in a stable manner in such a way that there won't be any sinkhole on top of it, because it is a very, maybe in the traffic area or maybe in the high-rise building nearby or maybe some local old buildings nearby. So we may need to study the proper settlement and we need to assess the settlement behavior in case if we find the particular building is unsafe. So we need to strengthen it and we do underpinning and before TBM pass through these regions. And not only that, this is another challenges what we have in underground constructions using tunnel boring machines. And also we do mine tunnels when we find that soil condition is good. So we did most of mine tunnel systems in Qatar Metro where you have a limestone. It can stand its own and most of the limestone. So we go with mine openings and then we just grout it inside. And we also have say even for open excavation when the soil condition is good, we lay a minimum reinforcement, then we grout it. It's like cement mortar grout we use. And for box posting, we do when we have a longer road which not possible to divert the traffic. When we find that the traffic condition is not possible to divert, or the particular monument buildings we can't able to avoid, so we go with the box pushing systems, construct the precast and then push it from one end. Then we can, the both side of the road, so we can push from one end and then it get connected to other. So it to main the forces friction of the concrete and versus the soil. So also here also we need to maintain the settlements. We need to make sure that the above ground should not get impacted. So think about the global challenges what we have. The concept looks simple, but when we push what degree of accuracy we need to apply on, what the equivalent forces to be applied on, at the same time, how we are managing without impacting the above ground soil. And there are pipe jacking we do. Pipe jacking is another major issue. Say, for example, when we have a very longer road where we can't able to divert it. So we go with a concrete grout pipe. Pipe we insert with the concrete. And then once grouted, then so maybe I can show some videos. There are a lot of videos are there in YouTube, which we have done it in Bangkok. We have also done it in many Qatar. We have done it pipe jacking, one of the Doha shoot station area. So you can see here what we do. Just we insert the pipe, concrete composite pipe, or sometimes we go with even hollow pipes. We insert it. So small pieces and get connected it. Then we do this once pipe get connected on both sides, we create a chamber. This is through sheet pile. The sheet pile to be designed for the lateral load as well as your whatever the traffic load, overburden loads. And we do this once all getting connected. Then this will provide a shield. I can push this. Once if I have enough, then I can push the precast box, tunnel box underneath the ground. So this is another easy way of doing pipe jacking systems. So another one which we have done it in Bangkok for pipe jacking systems. Maybe this pipe roof, we have done it. So this is along with the ICOM we have done. So what we do, so we construct a D wall, then we create a chamber. So this D wall is designed for the lateral load, then we create a pipe jack. So wherever we do even half station diverting, then do the pipe jack, pipe roof create, then go below underneath, do the excavation.
Sir, Selvachandran sir,
Mhm.
can you put it in the slideshow, sir?
Oh, okay. Yeah.
Yes, sir. Okay.
So this mean what we do here is the sequences. We construct the D-wall and then pipe roof to be constructed. This is one of the projects in Bangkok. So there are a lot of benefits of going with that. Only we can go for a top-down method. We can also use it for permanent case. So when we go for a deeper toe level, D-wall can be reduced when we go with the pipe jack systems. And yeah, what we do this here, these regions, we do this pipe jack, then we go down further. So once pipe jack done, so we excavate here and then we do the pipe jacking. Then this is the pipe from elevation. Then once done, then we can start excavate underneath. Then we can start constructing. See, you go down and we construct a beam, lintel beam kind of thing, capping beam. Then we open and we go underneath. We start construct the stations. Not only the challenges on pipe roofing, also we do have challenges in not only that. So there are many challenges of utility diversions, utility identification. There may be a gas pipe. So when we are not properly identifying, it will be a big problems. And utility diversions, maybe we have done it in one of the Tyagaraja College near Chennai. The soil is totally contaminated because of the BPCL petrol leakage, so oil leakages, which causes problem when we excavate. The contaminated soil leads, there is a possibility of the fire may occur. So what we have done like aeration method. Then we treated the complete soil and removed the complete soil. So utility diversion is another big global challenges which we need to look at it. And also we have underpinning where we have a major maybe big structures underneath, say for example, like viaduct structures rest on proposed station structures. So we may need to go for underpinning systems. Say this is the existing structures. So this is the proposed underground station construction. So we go for underpinning systems. So we adopt a simple concept of underpinning generally. Yeah, just one simple, concept I will just demonstrate. What we do generally when we go for underpinning systems, we excavate to the pier cap, whatever. Then we support laterally. So this will be a king post. Sometimes the seat pile we provide. Then we provide studding to support the pier cap. And this is the pier. And this is all lateral support for the pier cap. So we excavate up to this level. And then what we do, we go for constructing a transfer slab. So we cast a concrete pile or maybe steel pile or whatever the requirements based on the loading. Then we construct a transfer girder slab. So this slab will transfer the complete load from above ground roof or maybe viaduct structure load to the slab. So what we do then, we construct so we lay a hydraulic jack underneath. We go underneath and lay a hydraulic jack. Then the hydraulic jack get lifted up. Completely, it will push the whole pier cap. So the whole stress get released and into the pile and get transferred to the transfer slab. So once the whole load is transferred to the transfer slab, we go down below and we cut the pile. So this is the simple underpinning works we do for a big complicated systems. So we go down and then we cut the pile. And this is one simple approach we adopt for the deep excavation methods. Also, we need to choose a proper construction methods with respect to the soil condition, with respect to the adjacent lateral load conditions. Not only that, we also need to monitor it. So because not just designing, not just planning, we also ensuring whether properly the behavior is as per what we assumed or what we designed for. So we have monitoring systems. So we have various settlement markers. We have a tilt meter. We have a load cells, inclinometer. So it all integrated globally. So it comes into the server. So one engineer dedicatedly will review each diaphragmal movement or each excavation level, how the behavior, and it goes to the individual system, and they can easily plot the settlement of each stage, and we can assess how the structure is behaving. So based on that, we can take a decision on what kind of improvements to be done. I hope I can stop here because there are more slides to show. Maybe we can have a question session and then we can discuss further on this. Any questions?
Participants, who have
Yeah,
any questions?
participants, regarding the presentation, if you have any doubts or question, you can ask or post them in the chat box to get it sorted by the guest speaker.
Yeah, there are a lot global changes. Just I'm holistically explain what are all the various underground methods we adopt and what are all the challenges behind that. So which we need to mitigate case by case for say this is one particular case Godan test. So not only we do the we also assess the soil at each depth level and understand whether our assumed soil as per borehole data and when during the construction whether both are matching. If it is not matching, what kind of solution to be given. So these all we need to equip our knowledge in such a way that to resolve the technical issues on site conditions. Any questions? Sorry, I have a meeting at 4 o'clock. That's why I just stopped at 3:45. So, or else I could have continued some more time.
Yes, sir. There is one question, sir. MLHP?
Yes, sir, I'll read it out.
Yeah, I can read it.
Yes, sir. Sir, can you tell for which type of soil and other factors the underground metro station is not at all possible to construct?
There is no condition like that because whatever may be the kind of soil, still we can always look at underground. Only we need to select which type of construction method that play a role. Say we do even the underground construction near seashore area, filter soil area, even we do it in a clay area, clay soil area. The major point is we need to choose what kind of construction methods. Even we do freezing techniques. See some of the project, we freeze the complete water table into ice so that then we start excavate underneath and we construct it. Some location we go for a floating foundation concept. Some location we go for a bottom-up method. It depends on which method we choose. I can see the questions now, okay? Can you tell which type of soil, okay? Geotextile used practically in construction and how it is type decided. This geotextile generally for underground station structures, we are not using it. When we go for a, generally when we go for a slope stabilization, they use this geotextile. And when we go for underground retaining wall, anyway, we have a strong retaining wall systems, or we have a strong soldier pile or maybe sheet and pile systems. So we have a many diaphragm wall systems, retaining wall systems. So normally we are not using the geotextiles, and instead we design the connection between the wall or we grout it. Generally, the geotextile is useful when the water flow along with the soil comes in. It will be very dangerous. So when water flows, it will not. So when we are excavating down for a 10 meter down, and when water flows, if it's carry the particles of soil as well, it will be a problem. There is a possibility of sinkhole may occur on the ground. So in order to avoid, we always go for a membrane to protect the soil not to flow along with the water. How to encounter a pile foundation of existing building while UG tunneling on this. This pile foundation of existing building. So there are two things. When you do tunneling, we have a UV ray in front of the cutter. The UV ray will pass through. Then we always assess the density, the velocity. So when the velocity of the UV ray passes and the receiver, based on that, we assess, okay, what kind of soil, if any changes are occurring or not. And also, we can do some pile foundation if we assess the pile foundation is present in front of it. There are locally, we can check from the top. Once if you know that, better to remove it, or there are, we can change the cutter head in such a way that to cut the concrete. So we also cut rock, we also cut heavy, high density rock. So we can even cut the pile. As long as the loading, we are doing other way of underpinning works, and when you do for the building, then you can cut the pile even. But this is a big challenge, you know, because some old buildings, they may not have the data, what depth of pile, and we may not know whether the pile is a friction pile or end-bearing pile. So whenever the pile comes in, we always keep an eye and understand the building or maybe the flyover, whatever, and we do the potential damage assessment, and accordingly we decide on. Any other questions? Also, I will add some more points on these challenges in underground. The behavior of structural behavior and geotechnical behavior, someone should be thorough on, or else the behavior on simply relying on software is not going to resolve the problem. So they need to rely on when each stage of construction, how the behavior, then only you can able to design the structures. See what we do, the building above the tunnel demolished of the alignment of tunnel. So what generally we do in Singapore, we take 3 times of diameter of the pile, or generally 3 meters we take above the tunnel. If there is a pile presence, we leave it. In case if the pile comes in, we also do debonding method. So pile debonding method, another option we adopt. So when we do pile debonding, so the load in the critical zone of tunnel pass-through area will not pass, then it will pass only underneath. So that particular region, it will not be a friction pile, it will not be a end-bearing pile. So we do debonding method. If you go through debonding methods, there are so many methods are available. You can see in YouTube or you can see. So pile debonding method is another one of the good options. We can avoid it when there is a pile above the tunnel. Or in case if we cannot able to avoid that, we can also check the tunnel for the capacity of for the additional pressure due to the building loads. Generally, we avoid because the settlements, even if you go with the volume loss of say 0.5 or 0.25%, it is very difficult to achieve. So that is why we try to avoid. But pile debonding is one of the good options which we can always look at it. So we go with the transfer girded slab systems. We have done many in Singapore. So whenever there is a tunnel pass through area, there is a possibility of foot-over bridge fall on it, or maybe our viaduct fall on it. So what we do, we always keep the pile away, then construct a new pile, then construct a transfer girded slab and release the pile load so that there won't be any load transfer to the pile. Then the TPM will easily cut through it. So the current challenges in underground metro, even IIT, they introduced one courses for metro rail projects. Now huge demand in Chennai metro. There are 116 underground stations, 116 stations, including underground stations of around 13 and 49 underground stations. We have a metro light systems. It's a good challenges ahead of civil engineers, so they can always welcome to join here.
Thank you, sir. Thank you.
Sir, can we close it formally with a word of thanks?
Any other participant? No, we have to put the feedback link, ma.
Okay, sir.
Participants, any queries, any questions, you can ask now or put it in the chat box.
Thank you all. Be safe. Be home. Be safe in your home. Gopalakrishnan, I can leave now because I have another meeting maybe.
Okay, sir. Thank you, sir, being with us and delivering a good lecture about the underground metro rail transport system. Thank you, sir, once again.
Yeah, thank you. I have another meeting to go. Thank you.
Okay, sir. Okay, sir. Thank you.
Yeah.
Yes, sir.
Sir, Gopalakrishnan, sir.
Yes, madam. Formally, we can close, I think.
Sir, can you share that sir, which is having the feedback link?
Sir?
Yes, madam.
Sir, can I close it with a word of thanks?
Yes, madam. Yes, you can close it.
Towards the end of today's session, I'm here to present a vote of thanks on behalf of Department of Civil Engineering. I extend my profound gratitude to the guest, Dr. Selva Chandran, for spending his valuable time in today's webinar. I thank each and every one of you, all the participants, for taking your time to participate in this event on innovative technology in civil engineering. I sincerely thank the management, principal, head of the Department of Civil Engineering, Dr. S. Lavanya Prabha ma'am, and all the coordinators from the department for arranging this technical webinar series as an excellent exposure to all the participants here. Once again, I thank each and every one of you for attending the day one program of this international webinar series on innovative technology in civil engineering and getting the best done out of it. Thank you all.
Thank you, MLHP. Prabha, madam, we will close now.
Yes, sir.
Okay, madam. Thank you, madam. Okay.
Thank you all.
Thank you all for attending. Thank you for attending.
All of you fill the feedback link, and after filling, you can leave.
Kindly fill the feedback form and send it to us.